So we were at the infinitesimal force being minus g times little m times 2 pi a squared sigma sine theta d theta. We ended up dividing by r squared. We have to write everything in terms of the variable of integration theta. We have a cosine phi, and we end up with a, well, I think we wrote this as k hat. We could write a z hat too. It looks like that. Let's make our drawing again. Right, here's our sphere. Here's the object of mass little m, point object. This object here instead is uniformly, the mass is uniformly distributed, and we have, this was an R, a capital R from here to here, and we had a little shell here. Instead of drawing that whole thing, there's a little shell here, and we're integrating on these shells from all the way from here down to there. And so that little, there's a distance to there of r. There's an angle here. This is the angle we call phi. And then from here to there is theta. And this is the radius a. And so this r is, in magnitude, it's the difference of, well, we think of vectors, capital R here and a. So really, we could think of these as vectors. It's the difference between a vector, capital R, and a vector a. Right, if this is the origin of a coordinate system, these are the two vectors. This one is the difference of those two. We want r squared. So what we want is r squared plus a squared minus 2ar cosine of theta. And so our df now becomes, well, let's notice that cosine of phi, the cosine of phi is adjacent over hypotenuse, and so we can think of adjacent over hypotenuse, and this is r minus this, so the adjacent side would be r minus a cosine theta, because this side is a cosine theta, and we divide that by r, and r is given over here, so we end up with cosine of phi being r minus a cosine theta over r squared plus a squared minus 2ar cosine theta. That's r squared, so we want this to the 1/2, right? Because we want to divide by r, not by r squared. And so the df becomes minus g little m times 2 pi a squared, the density, sine theta d theta, r minus a cosine theta, k hat, let's make a little line here, over r squared plus a squared minus 2ar cosine of theta. This ends up being, we have a half here, and we have an r squared there, and so we end up getting a 3/2 coefficient there, exponent. And so, where are we? So f is minus 2 pi, let's pull out some constants, little m a squared sigma, k hat. We're integrating r minus a cosine theta, sine theta over r squared plus a squared minus 2ar cosine theta to the 3/2 in the theta, and we're going from theta, right? Theta is a little ring here, so theta is 0 all the way to a little ring down here, and so theta goes to pi. So we're going from 0 to pi in theta, and well, we could actually, I'm not sure if we can even look this up, but there's a different form that we can write this in. We can change variable to do this, and that's what we'll do in the next lecture.